What is the purpose of studying color, which connects space and time? When we think in terms of spatial concepts, one dimension is a world consisting of only length. If we lived in was a one-dimensional world, the world would be a line and people would be dots on it. In this world, we can only move forward or backward. A line is a length with no width. If a man in this world were to come across a tree, he would not be able to move forward anymore. Because there is no width in a one-dimensional world, the man is not able to go around the tree. Also, there is no height in the one-dimensional world, which means that the man can neither jump over the tree nor dig a tunnel under it. If a new tree started to grow behind the man, he will have to spend the rest of his stalk between the two trees. Likewise, is not possible to go past someone in a one-dimensional world. This world is so narrow that if a slow-moving man is or a broken car is in front of us, we have no choice but to follow behind it. If we were to consider the concept of time as we did with space, we may also think of it as a one-dimensional world. A difference from the one-dimensional space is that the concept of time can only move in one direction. In a one-dimensional space, we can move forward and backwards, but with time we can only go forward. People living within time cannot turn back time, nor can they skip time ahead. Then is there a way to connect time and space? Color can connect time and space. It is a key visual design element that the human eyes first recognize. People are attracted to different colors depending on their mood. They choose the color to represent them according to how they feel. On gloomy days, we often choose vivid colors to give off the opposite feeling or mood. This reflects the psychology of wanting to show the gloomy feeling and not wanting to show others our current mood. Mathematics is closely related to human happiness. People today tend to be lonely and depressed. How great would it be if there was something that could soothe the loneliness and comfort the subtle emotions? Humans live in the face of a myriad of the present, made up of a combination of dimensions of time and space. So, in order to get out of a bad mood, it is best to use colors, which can connect time and space. Color, which connects time and space, has a close relation to the human mood depending on what form it takes in the light. Yellow is a color that closely resembles light, making it appealing to those that want a bright color. Someone who wants yellow shows the longing for the brightness and warmth of light. A person wearing yellow expresses the many feelings of joy and expectations, such as hope, excitement, cuteness, loneliness, longing, happiness, love, and reunion. The light that brightens up the world does so to reveal what was hidden in the darkness while giving off warm hope. The stronger the light, the thicker the darkness. In The Bedroom in Arles, Vincent van Gogh used colors to express the feelings from his unhappy days and the yearning for the happiness he could not have. The yellow that expresses his mental state shows dark and gloomy feelings that were inside him. Colors can be used as messengers for space to convey messages of hope to time. The movie Les Parapleurs de Cherbourg is a musical about the love, loss, and loneliness of young people. The harmony between the pastel tone set and colorful costumes is what makes the movie so impressive. Alongside the yellow raincoat and umbrella that represents the female-led character Genevieve, pastel tones were used for pink walls paired with pink costumes, white walls paired with white costumes, and the light blue floral patterns on the wall paired with light blue costumes. Full of bright and soft pastel tone colors, the movie is trying to convey a bright image of unfortunate and impossible love. The pastel tone colors guide the hopeful images of space to the dimension of time. Why do we time and space out of the various math subjects? We refer to someone who thinks narrowly about a subject or acts without thinking as being one-dimensional. On the other hand, someone that acts randomly without thinking twice called four-dimensional. These expressions are not always used to mean positive things. Nevertheless, they both have an advantage. Those who think in one dimension can think more deeply about a given problem, while those who think in four dimension can discover a new perspective by thinking outside the box. It is impossible to understand the world we live in at one glance. We need to observe closely at a lower dimension as well as see the whole picture as we go up the dimensions. The same goes for studying mathematics, a study for discovering the secrets of nature. It is a difficult task to see and recognize the repetitive creation and destruction of nature at a glance and find regularity within it. That is why we need to train ourselves by observing from a lower dimension and then gradually observe from a higher dimension. In more difficult terms, we need to think in micro and macro terms. Observing and analyzing a world so small it is indistinguishable by the human senses through the microscope is called microscopy in natural sciences. This is a method used for studies of molecules or atoms of matter. The macroscopic method refers to the comprehensive study of the ecosystem, the world where us, humans, and all the plants and animals live, and every element within it. Then, what is time, a component of dimension? Why can time not move backward, unlike space? Time is a dimension in that it always insists on moving from the past to present into the future. The constant flow of time can be expressed as a straight line. This is something that is also recognized in Christianity. In time that follows like a straight line between the very first moment of God's creation to the end point that awaits the last judgment, all changes in this world unfold itself like a movie. In contrast, Indians believe that even if time flows forward, it will eventually come back to the beginning. This is because they built their concept of time based on the concept of repetition easily seen in nature, such as the movement of celestial bodies, the life and death of plants and animals, and the cycle of seasons. What is the logical evidence that time and space can be divided infinitely? Straight and curved lines in geometry are one-dimensional figures. The location of a point on a straight or curved line can be expressed as a real number. Likewise, because time, which only flows in one direction, can be expressed as a straight line and points on the line correspond with different points in time, time can also be seen as being one-dimensional. Although time cannot be seen, we can understand the essence of time easily once we grasp the concept of lines. The most well-known story of time and space is Zenos' Paradox of the tortoise and Achilles. Achilles and the tortoise decide to have a race. They both start at the same time, with the tortoise having a head start of 100 meters. They both run at a constant speed, with Achilles being 10 times faster than the tortoise. By the time Achilles reaches the starting point of the tortoise at 100, the tortoise has moved forward by 10 meters. When Achilles moves forward another 10 meters, the tortoise goes 1 meter further. Every time Achilles reaches the tortoise's previous position, the tortoise will have moved forward by a little bit, so Achilles can never catch up with the tortoise. The Achilles paradox comes to such paradoxical conclusion because it assumes that time and space is made up of infinitely smaller parts. Zenos saw all elements in time that make up the universe as a continuum and used this paradox to show that time cannot be divided infinitely. At a glance, Zenos' paradox seems to make sense. However, this paradox occurs because Zeno considered time and space as being two separate things. If we were to only think of space in Zenos' paradox, it seems like Achilles can never catch up with the tortoise. However, once we put time into the equation, the solution to the paradox reveals itself rather simply. Points, lines, plane, and solids are basic figures that make up a space. There is no contradiction in the Achilles paradox if we were to try to understand it using only the concept of space. According to the way Zeno set it up, the road that Achilles runs and the tortoise walks on is a one-dimensional straight line. A straight line is a length without a width. Achilles may be able to run much faster than the tortoise that is walking ahead of him, but he can never catch up with the tortoise no matter how much he runs. It may seem natural in our heads that Achilles would be able to catch up very quickly, but no one has the audacity to speak up against Zeno's claims. The solution to this paradox lies in the concept of time, which transcends the concept of space. Zenos' paradox of the tortoise and Achilles only applied the concept of space. What happens if we add the concept of time to it? The world made up of time and space is a two-dimensional world. The moment the concept of time is added, Achilles and the tortoise is no longer running on a straight line but in a world of planes. Now Achilles has a track for himself while the tortoise has one too. Likewise, if we go beyond the one-dimensional world and look from a higher perspective, we can picture in our minds Achilles catching up with the tortoise and running ahead of it. Achilles has now a track to himself while the tortoise has one for itself. As such, if we move beyond the one-dimensional world of a line and look at the situation from a higher dimension, we can picture the image of Achilles catching up with the tortoise and running past it. If Achilles and the tortoise were to really have a race, Achilles would run past the tortoise in just over 11 seconds. One thing to note in this paradox is that the time it takes for Achilles to catch up with the tortoise gets shorter and shorter. Thus, it is contradicting to say that Achilles can never catch up with the tortoise because time comes close to stopping as the distance between Achilles and the tortoise becomes shorter. From Zeno's point of view, there is no movement because time does not flow. To understand this paradox in more depth, we must also understand the concept of infinity. In Zenos' paradox, Achilles can get endlessly close to the tortoise but never run past it. Achilles feels that his pride has been hurt and proposes a rematch. He then shoots an arrow at the tortoise 100 meters ahead of him. For the arrow to go 100 meters, it must first fly 50 meters. To fly 50 meters, the arrow obviously needs to go 25 meters first, and for the arrow to go 25 meters, it must first go 12.5 meters, the half of 25 meters. Thus, for the arrow to arrive at 100 meters, it must fly past an infinite number of halves of the distances, starting from a half of 100 and then a half of that half. Here, one thing is for certain, the beginning of a length always starts at the end point of the previous length. If time and space were infinitely dividable, there would be no such thing as an end or the last. Without an end, the beginning of what follows is also impossible. According to Zeno, this means that the arrow cannot move from where it started, meaning the flying arrow is not actually flying. Here, Zeno went a step further to state all is one in the end, and nothing does not exist, making change little more than an illusion of ignorant humans. The basis of change is motion. Zenos paradox that Achilles would not be able to catch up with the tortoise and that the arrow would not be able to move beyond its starting point indirectly proves that motion is impossible. No one was able to logically refute Zenos paradox at his time. Although Aristotle, Thomas Aquinas, Archimedes, and others all made their attempts, only to fail. Zenos paradox was mathematically investigated by Carl Weierstrass and Augustin Louis Cauchy's calculus, which was developed in the early 19th century. We can logically describe the moment Achilles overtakes the tortoise by using infinity of the function. The paradox as presented by Zeno proceeds by continuously dividing a certain length into halves, dividing 100 meters into half, 50 meters in half again, and then 25 meters into another half. In other words, Zeno worked on his paradoxes from the assumption that space can be divided infinitely. Zeno's thoughts were not of the abstract space for calculus that we can imagine in our heads today. This raises a question. Could we infinitely divide the actual space that is visible, audible, and touchable to us? The reason why Achilles can catch up with the tortoise was that he could overtake a spatial block that is made up of numbers much smaller than infinity within a set time. Then, can infinity exist? First, consider a set of simple natural numbers or integers, such as -3, -2, -1, 0, 1, 2, or 3. How many integers are there in this set? If we were to compare a set of natural numbers to a set of integers, which has more elements? Elements within the sets of natural numbers and integers can be paired up endlessly. However, this does not mean that just because both sets are infinite sets, the number of elements is also the same. There are cases where two infinite sets cannot form one-to-one correspondence, as in the case of natural numbers and real numbers. This is because natural numbers are a countably infinite set, whereas real numbers are an uncountably infinite set. As such, there are many different levels of small and large and infinite sets. Our common sense tells us that a part should be smaller than its whole. How could we possibly say that a set of even numbers, a part of the integers, is the same size of infinitely as a set of the integers? Could we count all the elements of an infinite set? George Cantor, who came up with set theory, said, "No matter how big a number is, I have a bowl to put it in, and no matter how many there are, I have a way to count it." As mentioned earlier, however, there are many different levels of infinity. No matter how small a number is, real numbers can be divided infinitely. For example, if we were to think about partial sets of real numbers made up of binary numbers 0 and 1, it has been proven that there is an endless number of binary numbers that can be extended infinitely. Numerous points in the space clearly show the flow of time. However, there is no sensory organ that specifically perceives time. We can recognize necessary senses through the eyes and ears, but recognition of time itself occurs through comprehensive processes using various sensory organs. Although we can distinguish the time in detail physically, we cannot distinguish its difference psychologically. For example, suppose that two light bulbs went out or there were two sounds with one occurring shortly after another. In this situation, we would not be able to tell the sequence of the events which lamp went out first or which sound came first and think that the two events occurred simultaneously. Only when there is a certain time difference, we can recognize which one of the lights went out or which one of the sounds came first. When we listen to the conversation among people and favorite music, we do not perceive them as disconnected fragments of sounds, but as sentences, melody, or rhythm. Length, which measures the one-dimensional world, is a spatial distance between one end of an object to the other end of it. The length should be distinguished from the height or thickness, which is a vertical distance, and width, which is a distance between sides. Length is used on the particular dimensions of an object that is subject to measurement. Area is the measurement of 2 dimensions and volume is that of 3 dimensions. In order to make a precise measurement of the size and quantity of an object, we have to define the standard of length first. The measurement of the length according to the standard follows after. In the past, the body parts of adult men were used as the standard of length. Today, however, the units of length are defined based on the distance light travels in a vacuum in a certain period of time. When there was no barcode, which is the one-dimensional combination of lines, people had to check every shelf at the market in order to keep track of inventory. However, with the invention of the barcode, there was no longer the need to go about with this tedious task. Barcodes made up of a few vertical black lines have brought incredible transformations to the distribution and logistics markets. The barcode was invented in 1948 from an idea of an American man selling vegetables at the University Festival. He thought that if we changed the Morse code, which is simple and possible to combine in an infinite number of ways into graphics, it would be possible to make signs expressing all the information of every product. This simple idea brought groundbreaking convenience to many people. It is said that the invention of the barcode started from 4 lines unconsciously drawn on the sand at the beach. The first barcode that appeared in 1949 was circular, so that it could be read in any direction. IBM then invented the horizontal barcode, creating the first global barcode system. Barcodes are read based on the principle of the different light reflections between white and black. When a laser beam is flashed on the barcode, the black lines reflect a small amount of light while the white spaces reflect a large amount of light. That is, barcode scanners read this in electric signals of 0 and 1 according to the amount of light reflected, which is then interpreted and sent to the computer in letters and numbers. One-dimensional barcodes contain various information, consisting of national code, manufacturer's code, product code, check digit, and more. In the past, the one-dimensional barcode mainly used, but we have recently developed a two-dimensional barcode known as QR code that connects cameras on smartphones to websites. QR code can contain 7,089 numbers and 4,296 English letters, which is as much as 100 times more than the one-dimensional barcode. Although the one-dimensional barcode could only express information horizontally, the two-dimensional barcode can contain information both horizontally and vertically. We expect to see the introduction of three-dimensional barcode that will allow us to read information through X-rays and ultrasonic waves in the near future. How are the one-dimensional world and human happiness related? As mentioned earlier, the barcode has a certain combination of black lines and empty spaces that can be interpreted as numbers, letters, or symbols. Almost all products around us have the barcode with black lines with identical length and different thicknesses. Small numbers are often written under it. We can easily find the barcode anywhere that needs to process data quickly and accurately, such as manufacture, logistics, inventory, hospitals, libraries, trains, airplanes, and more. Using barcodes can save time compared to writing or typing data one by one. And also, it can reduce errors occurred while entering data. Moreover, the barcode is still readable even if 98% of the lines and empty spaces are damaged, allowing customers to check information of products with ease. The US played a major role in making the barcode a driving force of establishing the computerized information system. The barcode first began as UPC, which was marked in groceries and general merchandise. Its use was finally well established in 1973, successfully reducing the waiting time at the cashiers in supermarkets. UPC is made up of 12 digits representing the type of a product, manufacturer's code, product code, check digit, and other information. The first digit indicates the product type. For example, 0 means that the product is groceries. 2 is for products that vary in weight, such as meat or fruits and vegetables. 3 represents medicines. Likewise, every product has its own code depending on the category. The 5 digits following after the product code are the manufacturer's code, and the next 5 digits are the product code. The very last digit is a check digit to check for errors in the barcode. The check digit can be calculated by adding the sum of numbers in the even-numbered places in UPC and the sum of numbers in the odd-numbered places, that is multiplied by 3. The final sum is made to be multiples of 10. Recently, the thin and linear semiconductor that can take fine measurements of electric and light signals has been invented. This nanometer-thick semiconductor is named OneDimensional Semiconductor to say that it is of an extremely thin line. The one-dimensional semiconductor is not only utilized many fields like a transistor, LED, and solar cell, but also can detect extremely weak electric signals generated by the human body. This will allow the use of these conductors to make biochemical reaction maps or artificial retinas. Old people often lose their sight due to age or diabetes. This is because when people age or become diabetic, the retina where the light comes into the eye forms an image is damaged easily. The retina is the organ most sensitive to light in the human body. Retinas are full of a countless number of visual cells that distinguish the shape, color, and light and darkness of objects. When the image of an object forms on the retina, the specific information about the object are delivered to the cerebrum through the visual nerves. It is impossible to fully recover the retina once it is damaged. Modern medical technology had not been able to completely restore the retina to its original condition when people lose sight due to retinal damage. However, a research team at Stanford University in the US has invented the artificial retina chip, making it possible to see objects. This chip could replace the retina in its reaction to light. The artificial retinal chip can perceive light in place of the visual cells making up the retina. Simply put, this artificial retina chip can act just like the retina and recognize the shape, color, and light and darkness of objects. The Stanford researchers received help from the augmented reality software developer in order to create this innovative artificial retina chip. The device they developed together consists of a little silicon chip that can be transplanted into the retina in a goggle that people can wear on their heads. Here, the device refers to the machine or equipment that is designed for a special purpose. It is said that when people with the artificial retina chip wear the goggle, the information of objects seen through the goggle is converted into the visual signals and transferred to the cerebrum. This device recovers vision to a level, but not to a point that allows for reading or safe driving. However, if we can further upgrade the artificial retina chip in the future, it will be able to fully restore vision to normal levels. Let us go now beyond the one-dimensional world and move into the world of images. Images refer to the visual information that is played or expressed in the 2- or 3-dimensional display using a particular technology. Images show the reality as it is or depict an imaginary world beyond reality. Compared to the text, images exist as inside the people's heads. The experience in the name of memory exists as images accumulated in the neural bundles located in the brain or mind. The memory also exists in the images created by cameras. Then, what are pictures? Technically, a picture and an image refer to the same thing, but we can say pictures are images that are temporary, such as movies or television programs. Signal systems that amplify or transmit images are called videos. Photographs, fax, and printing are also types of pictures by a broad definition. Pixel is the smallest unit that forms a picture. Pictures create colors of varying brightness with an arrangement of dots. The greater the number of pixels, the higher the resolution in pictures. Pixels can be usually distinguished as the full pixels and valid pixels. Full pixels mean the entire pixels, while valid pixels refer to those among full pixels where the image signal is actually printed. If we were to look at pictures on newspapers or books with a magnifier, we find a great number of dots printed at irregular intervals. Depending on the size of these dots, the outline and the depth of color of the pictures change. Since a one-dimensional point is the smallest unit required to make up a picture, points cannot be used to express anything smaller than itself. Picture information can be disassembled into many pixels arranged vertically and horizontally. By reading one-dimensional pixel signals and reading them again moving vertically, we can get two-dimensional pixel information. This method reads sufficient information when the document is written in texts, so one-dimensional image sensors are used in devices such as facsimiles.